Those prints are back. Let's take a look. Beautiful. Unfortunately, we're going to ruin this set. We'll be marking these up to compare with the actual Rev F board. Nice. Oh yeah, I wasted $1 American on this edge thingy. Just don't do it. Gonna rip it off anyway. Kind of in the way. Here we have the placement diagram from the manual. Way better than nothing, but still a little bit sucking. But if we rotate it, it still sucks. We know there are more components on the Rev F boards than on this diagram, so let's roll our own. I made up this drawing with the base parts from the manual, plus the additional ones found on the Rev F board. In this orientation, you'll notice that the site names generally flow from the top left corner, across the board, then progress down to the bottom right, kind of like a raster scan. Deviations from this pattern may point to changes made after the initial layout. Let's follow the components in order, starting with the resistors. In the top row, we have our 1, 2, 3, and 4. The next row has our 5 and our 6, and our 7 through 10. The next row has just our 11, then our 12, our 13, and our 14's way over here. She may have originally been in this area, who knows. Next we have 15, 16, and 17, then 18, 19, and 20, and 21 kind of between the rows but still within the pattern. Next row we have our 22 and 23, our 24, 25, and 26. Next row has just our 27, and the next row has our 28 and 29, then 30, 31, and 32. Next row has just our 33, then our 34, 35, 36 through 9, our 40's way over here, and then our 41 through 43 are back down here. So our 40 probably was in this area before. Still don't know. Bottom row has our 44, our 45 and our 46, our 47, 48, our 49, the potentiometer, our 50, and our 51 and 2. Now the next resistors are out of place and they may indicate post-initial layout changes. We have R53 here, then R54 and 55 grouping. R56 is not used, then they added R57 and R58 over here. The actual board has 2 additional resistors, so we'll mark them as R59 and R60 way in the bottom right corner. I added an asterisk to the site names of additional parts, and also while looking at this, I noticed our 41, 43, 51, and 52 are actually 330 ohm, not 3.9K, so we'll update this on the schematic as well. I didn't notice anything else, but there may be other value differences. I did mention before that when open collector versions of the bipolar RAM are used, they tie data out to VCC through a 4.7K resistor. We'll add this to the schematic as R61, and we'll add the site to our retro board as an optional component. The capacitors follow roughly the same pattern, roughly. We'll start out with C1, 2, 3, and C4 is way down here. May have initially been in this area, don't know. I'll add a plus sign to denote electrolytics in the value list. Then we have the decoupling ceramic, C4 through 13 across the middle. There are actually 9, not 7 as I said earlier, 1 for each column. Then C14, 15, and 16. Then 17, 18, and 19. Next row has C20, 21, 22, and we've got C23 over here. Finally, we have C24 and 25, 26 and 27, 28, 29, 30, and 31. Our out-of-place caps are C32, C33, and 34, and we've seen these resistors out of order as well. Then C35, C36, and C37. We have 3 additional caps on the actual board, so we'll mark them as C38, C39, and C40. The diodes follow a less distinct pattern. We have our 2 rectifiers, CR1 and 2 for the power supply, then CR3, 4, 5, 6, 7, and 8. The CR6 may have been over here somewhere. Once again, we just don't know. We have just 2 additional switching diodes on the real board, so we'll call these CR9 and CR10. Might as well do the other silicon while we're here. We have 3 transistors and these 2 SCRs. And we can't forget about our favorite linear space heater, the LM323. Oh yeah, that chip in Charlie 1 that's not on the schematic, it's a 7408 quad AND gate. As a final bonus for playing, here's a recap with just the new parts. It will be interesting to see how these fit into the schematic. Thanks to Jason Scott for mentioning this in his X-Post. We're really lucky to have some clean, high-res images of a blank Rev F board. You can find these on the Internet Archive as shown. You'll notice they only put solder mask on the, solder side for running through the wave machine, and no mask on the component side. Don't need it. Today we typically mask everything. Really nice resolution. I tried separating the traces from the substrate in Blender using a color ramp and key so we would have easy to follow X-ray versions. I couldn't get it perfect. A bit crappy, but we can use it as a guide. If anyone is good with images, perhaps you can make a pair of nice ones. Would make tracing a whole lot easier. Here is my component side render. You'll notice the traces run vertically, and my solder side with traces running horizontally. The solder side is more difficult to isolate because of the solder mask. The composite looks like this with a white background. And I like the black background with our component layout. I think we can use this for tracing and use the other images as reference. There's a little bit of trapezoidal error, so while perfectly aligned in some places, she's off in others. I don't know how to slightly stretch or shrink one edge to make it better. I should still be able to follow it for the most part. I did grab copies of those clean board images and added our site markings. The solder side has a flipped version of our transparent markup, so the labels will be backwards. I'm too lazy to change that. Then I specifically added a special mark on pin 1 of every chip site on both sides so we won't get too disoriented jumping back and forth, especially on the solder side. And I marked up the connector pins on both sides as well. Should help. I was originally going to put our regular images up on 2 monitors in MS Paint so we can mark them up, but I think we'll try the X-ray version first and see how that goes. We'll mark off the nets on both the screen and the physical drawings as we go. Not too high tech, but it'll work. So I'm actually going to open the component side and flip solder side in MS Paint on the same screen for easier recording. We'll start with the oscillator. This will get real boring, so we'll crank it up. We already said that since the boards work, we'll use the board as the reference and modify the schematic to match the board. After we get moving along, we'll step through each package starting on pin 1, then step through each pin marking those nets. Towards the end, more and more pins should already be marked, so the job should go faster. It's real easy to get lost, So when I come to a via, I halt the marker just before the pad. Find the other side and circle that pad, then come back and fill the original before continuing with tracing on the other side. It's a lot more difficult to draw straight lines than you think, and no, I wasn't drinking. I should have been drinking. And the lines get worse as a direct function of pain in the ass. There was probably a pad here at one point. There was probably a trace through here at one point. Like any decent pseudo-masochist, I also wrote a net list. Since we're covering up the traces and pads, it should be easy to see if we missed anything.
2,000 years later.
Finally, wow, that actually took a few days, and was about as fun as sticking your dick in a meat grinder. There are quite a few differences, so I'll document those and be back. As you can see from this list, there are plenty of differences with varying levels of significance. We'll create a new set of schematics that are updated to match the actual RevF board. I was originally going to call them RevFU, then I pulled my big boy pants back on and we'll just call them RevFX. I created this more detailed doc that I'll drop in GitHub, but let's take a quick look at the differences. Starting on sheet 1, in diff 1 we find our 2 new diodes and one of the new resistors. They basically created an AND gate and used it to suppress the left and right boundary signals during H-sync. Analog monitors are pretty sloppy, but these boundary signals were probably leaking too much. Again on sheet 1, in diff 2, this set bricks flip-flop is wired differently as shown. You can see modifications made to this Rev-C board, and this is built into the Rev-F board. Also on sheet 1, for diff 3, they changed out some of the 3.9K resistors in the video mixer to 330 ohm, and also added our new R60 across CR6. This effectively eliminates CR6 from the circuit. The normal thing to do would be to mix these signals in logic instead, but resistors don't add to the gate count. As a minor note, the schematic has the playfield and score labels reversed. Score drives R51 and playfield drives R52 on the actual board. Still on sheet 1, in diff 4, this serve weight flip-flop is reset by H-sync, not the 128H line. Again on sheet 1, diff 5 has different wiring for this particular line in the ball motion logic. Still on sheet 1, diff 6 has different serve logic wiring and also adds our new capacitor C39 here. Final item on sheet 1, diff 7 is another serve weight logic difference. Here we finally see our new Charlie 1 chip. Note that only one gate in the package is used. I guess they were way past worrying about chip counts at that point. Moving on to sheet 2, diff 8 creates simpler paddle logic as shown. You can see on the Rev-F board that the Henry 7 Baker gate is unused, and we'll add that to our, unused gate list. They could have used this gate for diff 7 instead of adding a new chip in Charlie 1. Still on sheet 2, for diff 9 we find our new capacitor C40 added to the 555 discharge and threshold. We also see capacitor C20 change from 0.01 to 1 mic on the control voltage line. There's a whole history of strange changes to this paddle timer in the dock, almost as if they unintentionally fixed the wrong thing at first. One more change on sheet 2. For diff 10, we see that our new capacitor C38 was added to the score chain. You can see a fix on Rev C board here and a permanent placement on Rev F. Moving on to sheet 3, for diff 11, the clock on this flip-flop is driven by 64 Victor 1 on the board, not 64 Victor Prime. 64 Victor 1 is a copy of 64 Victor coming off the cocktail mode logic. I think they probably meant for both of these to be driven off the base counter 64 Victor Prime. Absolutely no reason to modify a coin system signal when player 2 is up in cocktail mode. Finally on sheet 3, for diff 12, the bonus coin signal actually comes from this one shot. Back on sheet 1, I wanted to show the pull-up for open collector rams, so we'll include our new optional R61 here. A few quick minor notes. On sheet 2, Able 7 pin 11 is missing the dot indicator. Resistors R47 and 48 are swapped, as well as resistors R22 and 23. Nancy 5 has a different selector notation than every other MUX, so we'll fix that. And for all of the MUXes, we assure that both the used and unused outputs are labeled correctly. On sheet 3, the 1 credit start signal here should be marked as inverted 1 credit start. Again on sheet 3, these two pins are actually connected. And lastly on sheet 3, the reset line of this JK flip-flop should be pin 10, not 13. In general, we want to assure that all device pins are shown on the updated schematics for completeness. In Rev FX, we also show the specific pull-up that's used, and we name the pull-up nets from the associated resistors. On the original drawings, some things are out of place. You basically add stuff where you have room, so it gets a bit disjointed. In the updated drawings, you'll notice I took the liberty to rearrange a few things, so you'll see some minor moves to improve the flow. I think that's enough for today. I'll drop additional files in GitHub. Here are the 4 new updated Rev FX schematic sheets and the differences document. I added this PCB subfolder. In there you'll find the 2 blank RevF board images and 2 with our component markup and our own parts layout. For those still with us, we were going to start breadboarding next, but we'll have another short waylay. Last week I won a bid for an original Breakout arcade game. We had to drive 1,400 miles round trip from Chicago to Maryland over 2 days to pick it up. It's not 100% working, so we'll fix that. At least now we have a cabinet to test our retro version. We'll get this out and take a tour in the next video. Thanks for watching.